On May 31, 1918, German troops were preparing for another massive offensive against the positions of the French army during the Third Battle of the Aisne. And none of them could even imagine that in a few hours they would face a weapon that would completely change the concept of war for the next 100 years. When 30 small machines, standing just a little taller than a human, began to crawl out of the morning fog, the German soldiers did not understand at first what they even were. These iron boxes on tracks with rotating turrets seemed far too small and strange. However, a few minutes later, when the machine guns and light cannons of these tiny monsters opened fire, and the machines themselves began to methodically crush barbed wire and cross trenches, entire units of the Kaiser's army began to surrender in panic. This was the Renault FT tank, a machine weighing only 7 tons, which forever changed the face of war and became the great-grandfather of all modern tanks, from the American Abrams to the Russian T-90. To understand just how revolutionary this small French machine was, we need to go back a few years and look at what was actually happening on the battlefields of the First World War by 1917. The Western Front was a continuous nightmare of mud, barbed wire, shell craters, and endless trenches, stretching from the North Sea to the Swiss border over a distance of several hundred kilometers. Any attempt at an offensive turned into a bloody meat grinder. Infantry leaving their trenches to attack immediately fell under heavy enemy machine gun fire and suffered monstrous losses. 4 meters of captured territory were paid for with thousands of lives. And a week later, the enemy could recapture those same 4 meters, and everything would start all over again. The French army was losing hundreds of thousands of soldiers in fruitless offensives. The morale of the troops was dropping catastrophically. And in 1917, mass mutinies even broke out in several divisions, which refused to go into yet another suicidal attack. The British were the first to try and solve this problem technically, creating their famous diamond-shaped Mark series tanks in 1916, which first went into battle on September 15th of that same year on the Somme River. These huge steel monsters made an incredible impression with their size and ability to overcome obstacles. But they had a whole host of serious flaws that severely limited their combat effectiveness. First, they were monstrously slow. Their maximum speed was about 6 kilometers per hour on a flat road and dropped to 3 to 4 kilometers per hour over rough terrain. Second, the crew of 8 men suffocated inside from the heat and exhaust fumes. The temperature rose to 50 degrees, and after an hour and a half of combat, people would simply lose consciousness. Third, driving this behemoth was incredibly difficult. It took 4 men just to steer the tank in the right direction, and they had to work in perfect coordination. Fourth, the cannons on these tanks were located in sponsons on the sides of the hull and could not rotate independently, which created huge blind spots in their fields of fire. The French also tried to create their own tanks, but the results turned out even worse than those of the British. The first French tank was the Schneider, which began to enter service in early 1917. This machine, weighing 13.5 tons, was built on the chassis of the American Holt tractor and looked like a long box on tracks with a short nose at the front. The armament consisted of a short-barreled 75mm cannon in the right sponson and 2 Hotchkiss machine guns of 8mm caliber. The crew of 6 men was housed in a cramped compartment where infernal heat reigned. And the concentration of exhaust fumes was such that people regularly lost consciousness right during a battle. But the most terrible flaw of the Schneider was its catastrophically low cross-country ability. The tank had a very high center of gravity and a short track base, which caused it to constantly get stuck in shell craters, roll over when crossing trenches, and generally behave highly unpredictably on rough terrain. The combat debut of the Schneider on April 16, 1917, during the Nivelle offensive, turned into a real disaster. Out of 132 tanks that went into the attack, 57 were destroyed or knocked out, and most of the rest got stuck in the mud or craters. The second French tank was the Saint-Chamond, which was even more unsuccessful than the Schneider. This machine, weighing 23 tons, was the heaviest tank of the First World War and represented a simply monstrous design. It was a long hull on the chassis of that same Holt tractor with a huge nose overhang where the 75mm cannon was located. The crew consisted of 9 men who were housed in a cramped compartment and practically suffocated from the heat and gases. The Saint-Chamond was better armed than other tanks of that time. In addition to the main gun, it carried 4 machine guns of 8mm caliber, making it a real mobile fortress. However, the cross-country ability of this monster was even worse than that of the Schneider. The long nose overhang constantly dug into the ground when overcoming obstacles. The tank got stuck in trenches just 2 meters wide, rolled over on the slightest slopes, and was generally completely unsuited for action on the crater-pitted terrain of the Western Front. In its first battle on May 5, 1917, out of 16 Saint-Chamond, 15 got stuck without even covering 100 meters from the front line, and only 1 tank managed to reach the German positions. The French command understood perfectly well that both of their tanks represented a dead end in development, and it was urgently necessary to create something fundamentally new. The main ideologist of the French tank forces was General Jean-Baptiste Estienne, who had been interested in the possibility of using armored vehicles on the battlefield even before the war and closely followed all experiments in this area. Estienne believed that tanks should not operate alone or in small groups, as the British practiced, but in massive formations, literally overwhelming the enemy with the sheer number of machines. However, to implement such tactics, they needed cheap, easy-to-produce, and reliable tanks that could be manufactured by the thousands rather than by the hundreds. The Schneider and Saint-Chamond were too complex, expensive, and unreliable for mass production. Therefore, Estienne began looking for a designer who could create a fundamentally new machine. Estienne's choice fell on Louis Renault, the famous French automotive industrialist and designer, whose company by the beginning of the war was one of the largest automobile manufacturers in Europe. Renault had become famous back at the very end of the 19th century, when, at the age of 21, he created his first car with a direct drive to the rear axle through a gearbox, a solution that became standard for the entire automotive industry. By 1917, Louis Renault was 39 years old. His factories worked for the defense effort, producing trucks, aviation engines, and ammunition, and he himself was considered one of the best engineers in France. However, Renault had never dealt with tanks. He had absolutely no experience working with tracked vehicles. And when Estienne approached him with a proposal to design a new light tank, many colleagues considered this venture a hopeless gamble. Estienne set very clear requirements for Renault. The tank must be light, no heavier than 8 tons, so that it could be transported by ordinary trucks and railway platforms. It must be fast and maneuverable enough to break through the front line in a swarm and operate deep within the enemy's defenses. It must be easy to produce and cheap, so that it could be manufactured by the thousands. It must have a rotating turret with armament to fire in any direction without needing to turn the entire hull of the tank. And finally, it must be reliable and capable of crossing trenches, craters, and other obstacles on the battlefield. The task seemed impossible because all existing tanks were huge, slow, unreliable machines with fixed armament, and Estienne demanded the exact opposite. Louis Renault accepted the challenge and threw himself into working on the new project, which received the designation FT, an abbreviation from French meaning light tank. Renault approached the task as a true engineering innovator. He discarded all existing tank-building concepts and began designing the machine from a blank slate, guided only by common sense and the laws of mechanics. The first revolutionary decision concerned the layout of the tank. Renault placed the engine in the rear part of the hull, the driving compartment in the front part, and between them he installed a rotating turret with armament and a place for the commander gunner. Such a layout seemed absolutely logical. The engine in the back pushes the machine forward, the driver in the front sees the road and controls the movement, and the commander in the turret has a circular view and can fire in any direction. However, before Renault, no one had thought of using exactly this layout, and it turned out to be so successful that it became the standard for all subsequent tanks for a whole century ahead. The second revolutionary decision was the rotating turret itself, which today seems to be a completely natural element of any tank, but in 1917 represented a real engineering puzzle. All existing tanks had guns rigidly fixed in the hull or in side sponsons, which created huge blind spots and forced the entire multi-ton machine to turn in order to aim the gun at a target. Renault understood that for a light, maneuverable tank, which was meant to operate deep in enemy defenses surrounded by the enemy, the ability to fire in any direction was absolutely vital. The problem was that the turret had to be light enough to be rotated manually by the strength of one man, but at the same time strong enough to withstand hits from bullets and shell fragments. Renault designed a cylindrical turret out of rolled armor steel 22 millimeters thick, which was mounted on a ball bearing and could be rotated 360 degrees by the effort of the commander sitting inside. The design turned out to be surprisingly simple and reliable. No complex mechanisms, no hydraulic or electric drives, just high-quality machining of parts and precise fitting. Renault's third stroke of genius was the design of the chassis with a characteristic rounded tail skid, which became the calling card of the FT tank. This element did not appear for beauty, nor by accident. It solved the critically important task of crossing the trenches that scarred the entire front line. First-line defense trenches usually had a width of about 2.5 meters, and if a tank with a short track base tried to cross them, the front part would fall into the trench, the tank would stick its nose into the ground, and the rear part would rise into the air, after which the machine would get hopelessly stuck and become an easy target. Renault lengthened the track base by adding the rounded tail, which touched the ground and prevented the rear part of the tank from lifting up when crossing a trench. When the front part fell into the trench, the tail rested against its far edge and served as a support, allowing the tank to smoothly roll over the obstacle and continue moving. This simple and elegant solution worked flawlessly and allowed the FT to cross trenches up to 1 meter and 80 centimeters wide, which covered the absolute majority of trenches on the Western Front. The tracked chassis of the tank consisted of 2 large-diameter drive wheels in the rear part of the hull, to which power was transmitted from the engine, smaller idler wheels in the front, and 5 road wheels on each side. The tracks were relatively wide, which ensured a good distribution of the machine's weight over the surface and allowed it to move over soft ground without sinking. The suspension was as simple as possible, rigid, without any shock absorbers or springs, which made riding inside the tank an extremely harsh ordeal for the crew, especially over rough terrain. However, this design was reliable, cheap to produce, and required practically no maintenance, which fully met the concept of a mass-produced tank that was supposed to be manufactured by the thousands. For the power plant, Renault used a gasoline engine of his own design with a volume of 4.5 liters and 4 cylinders, which developed a power of 39 horsepower at 1,500 revolutions per minute. By modern standards, this looks ridiculous. 39 horsepower is barely enough for a scooter or a lawnmower, but in the context of 1917, it was quite decent power for a machine weighing 7 tons. The engine was started either by an external starting crank, which was inserted through a special hole in the rear part of the hull, or by an internal crank, which the driver could use, although it was extremely inconvenient in the cramped driving compartment. The fuel tank held 95 liters of gasoline, which provided a cruising range of about 48 kilometers on the highway or 30 kilometers over rough terrain. The transmission included a gearbox with 4 forward speeds and 1 reverse, giving the tank a maximum speed of 7 kilometers per hour on a flat road. The tank was controlled by the driver, who sat in the front part of the hull and had extremely limited visibility through a small viewing slit. To steer, two levers controlling the track brakes were used. It was a classic system that was applied on all tracked vehicles of that time and is still used today. By pulling the right lever, the driver braked the right track and the tank turned right. By pulling the left lever, it turned left. For a sharp turn on the spot, you had to completely brake one track and step on the gas. Then the tank would pivot around the stationary track. The system was simple and reliable, although it required significant physical effort from the driver, especially on heavy ground, where he constantly had to work the levers to correct the direction of movement. The armament of the FT tank was presented in two variants, cannon and machine gun. The cannon variant carried a short-barreled Puteaux cannon of 37mm caliber, which was specially designed for installation in a tank turret and had a barrel length of only 21 calibers. This cannon did not boast a high muzzle velocity and was quite ineffective against armored targets, but it did an excellent job of destroying machine gun nests, bunkers, clearing paths in wire entanglements, and engaging enemy personnel with high explosive fragmentation shells. The ammunition load consisted of 237 rounds, which were stored in racks inside the turret and hull. The machine gun variant was armed with an 8mm Hotchkiss model 1914 machine gun with an air-cooled barrel, which was fed from rigid metal strips of 24 rounds. The machine gun's ammunition load was 4,800 rounds, which ensured a sufficiently prolonged battle without reloading. The crew of the tank consisted of only two men, a driver and a commander, who simultaneously performed the functions of a gunner, a loader, a machine gunner, and an observer. Such a minimal crew was possible due to the compact size of the machine and the simplicity of its design, but it created an enormous burden on the commander, especially in combat. The commander had to rotate the turret, search for targets, aim the gun, load it, fire, monitor the situation, correct the driver's actions, and make tactical decisions. All this simultaneously in a cramped, stuffy turret under enemy fire. The driver didn't have an easy life either. Driving the tank required constant physical effort. Visibility was minimal. The noise of the engine and transmission was deafening. Exhaust fumes seeped into the driving compartment. And when moving over rough terrain, the tank shook so much that the driver constantly bumped his head against the walls of the hull, even while wearing a leather helmet. The armor protection of the FT tank was differentiated. The frontal part of the hull had a thickness of 16 millimeters, the sides and rear were 8 millimeters, and the roof and bottom were 6 millimeters. The turret was protected by armor 22 millimeters thick in the front and 16 millimeters on the sides and rear. Such protection was sufficient against rifle and machine gun bullets at all distances, as well as against shell fragments, but it could not withstand a direct hit from an artillery shell, even of a small caliber, or a shot from an anti-tank rifle, which had begun to appear among the Germans by the end of 1917. However, Renault never intended to have anti-shell armor. It would have made the tank too heavy and expensive, and the concept of using the FT implied a breakthrough deep into the enemy's defenses, where the tanks were supposed to operate against infantry and unarmored targets, avoiding encounters with artillery. The first prototype of the FT tank was ready by the end of February 1917, which in itself was an incredible achievement. Only a few months had passed from the start of the design process to the creation of a working prototype. On February 22nd, the prototype was demonstrated to a military commission at a proving ground in Champagne, and the test results exceeded all expectations. The small tank easily crossed trenches, shell craters, wire entanglements, and moved through mud and up slopes, displaying maneuverability and cross-country ability unavailable to heavy tanks. General Estienne was thrilled and immediately demanded that mass production begin, and in the maximum possible quantities. However, skeptics in the War Ministry doubted that such a small machine could be effective on the battlefield and insisted on additional tests and refinements to the design. Louis Renault continued to perfect his tank throughout the spring and summer of 1917, eliminating identified flaws and improving the reliability of components and assemblies. Changes were made to the transmission design, the suspension was reinforced, the engine cooling system was improved, and the turret design and its rotation mechanism were refined. By the autumn of 1917, the design of the tank was finalized, and preparations for mass production began at the Renault factories and several other French enterprises. The French command planned to receive the first batch of 3,500 tanks by the spring of 1918, which would allow them to conduct a large-scale offensive using the new equipment and turn the tide of the war in favor of the Allies. Production of FT tanks began at the end of 1917 simultaneously at several factories, including Renault's own facilities, the Berliet factories in Lyon and Saumur in Saint-Ouen. The manufacturing technology was simplified as much as possible. Armor plates were cut with guillotine shears and assembled on a frame using rivets, which did not require highly skilled workers and allowed production volumes to increase quickly. Engines and transmissions were manufactured at Renault automobile plants using already established technologies. Tracks and road wheels were ordered from metallurgical enterprises, while turrets were stamped at artillery factories. By the spring of 1918, production had reached full capacity, and tanks began arriving at the troops by the dozens every week. The French command formed special tank companies of 20 machines each, which were supposed to operate jointly with infantry units, supporting them with fire and maneuver. Crew training was conducted at a specially created tank training ground in Champleau, where drivers and commanders mastered vehicle control, firing from cannons and machine guns, overcoming obstacles, and interacting with infantry. Crew training took from 2 to 3 weeks, which was significantly faster than training pilots or artillerymen. Many tankers were recruited from among mechanics and truck drivers who already had experience working with engines and transmissions, which significantly accelerated the training process. By May 1918, the French Army had several hundred combat-ready FT tanks and trained crews prepared for combat deployment. The first 30 tanks went into the attack in a forest near the village of Villers-Cotterêts, where German troops were trying to develop their spring offensive and break through to Paris. The French command decided to use the new machines for a counterattack, which was supposed to stop the enemy's advance and stabilize the front. The tanks moved to their starting positions early in the morning in a thick fog, which hid them from enemy observation. When the fog began to clear, 30 small machines simultaneously moved forward in a broad line, crushing barbed wire and firing from cannons and machine guns at the German trenches. The German infantry opened return fire from rifles and machine guns, but the bullets bounced off the armor plates without causing any harm to the tanks. A few anti-tank guns opened fire with direct aim, but the tanks maneuvered quickly, changing direction, and the gun crews did not have time to aim. The psychological effect of the tank's appearance exceeded all expectations of the French command. The German soldiers, exhausted by 4 years of trench warfare and accustomed to the fact that the main danger was artillery fire and machine guns, were completely unprepared to encounter armored machines that trampled their fortifications with impunity and shot up their trenches at point-blank range. Many German units began to retreat without putting up a fight, and some even surrendered in whole platoons at the mere sight of the approaching tanks. The French infantry advancing behind the tanks suffered minimal losses and moved forward quickly, capturing one position after another. By the end of the day, the German offensive was completely stopped, and in some sectors the enemy was thrown back several kilometers. The success of the first combat deployment of the FT tanks convinced the French command of the correctness of the chosen concept of the mass employment of light tanks. General Pétain, who by that time had become the commander-in-chief of the French army, ordered an increase in tank production to the maximum possible level and the formation of as many tank companies as possible for the upcoming summer offensive. By July 1918, the French Army already had more than 300 FT tanks, and they were actively used in all major operations on the Western Front. The American Army, which had landed in France in large numbers by the summer of 1918, had no tanks of its own and was completely dependent on French supplies of armored vehicles. The French command handed over 144 FT tanks to the Americans, forming the basis of the first American tank units. The command of these units was entrusted to 32-year-old Captain George Smith Patton, Jr., a cavalry officer who had never dealt with armored vehicles before, but showed tremendous enthusiasm and interest in the new type of weapon. Patton personally went to France to the tank training ground in Champleau, where for several weeks he studied the design of the tanks, the basics of their operation, and deployment tactics, after which he began forming and training American tank crews. Patton turned out to be a born tanker and quickly understood all the advantages and disadvantages of the FT machines. He developed his own tank deployment tactics, which envisioned close interaction with infantry, a rapid advance deep into the enemy's defenses, and immediate exploitation of success without stops or regroupings. Patton personally participated in the training of the crews, drove the tanks, fired the cannons, overcame obstacles, and demanded maximum dedication and aggressiveness in combat from his subordinates. His first baptism of fire took place on September 12, 1918, during the offensive on the Saint-Mihiel salient, where American troops, supported by French units, attacked German positions along a front stretch of about 30 kilometers. Patton personally led the attack of his tanks, walking ahead of the combat formations on foot with a walking stick in his hand under enemy fire, showing the crews the direction of movement and encouraging them with shouts and gestures. When several tanks got stuck in craters and trenches, Patton organized their evacuation, personally directing the work under machine gun fire. The American tanks successfully broke through the first line of German defense, destroyed several machine gun nests, and cleared paths in the wire entanglements, which allowed the infantry to advance with minimal losses. For this battle, Patton was awarded the highest American award for bravery and received the rank of lieutenant colonel, and his tank brigade became one of the most effective units of the American Expeditionary Forces. The 100 Days Offensive of the Allies, which began on August 8, 1918, became the finest hour for the FT tanks. By this time, the French Army had more than 3,000 tanks, which were organized into special tank battalions and brigades. The massive use of tanks along the entire front from the North Sea to Verdun led to the complete collapse of the German defense. Tanks broke through trench lines, destroyed strongholds, crushed artillery batteries, and sowed panic in the enemy's rear. The German army, exhausted by 4 years of war and lacking reserves, could not withstand such an onslaught and rolled back to the east, abandoning one position after another. In 100 days, the Allies advanced hundreds of kilometers, liberated all the occupied territory of France and Belgium, and reached the German border. The American command, impressed by the successes of the French tanks, decided to set up its own production of the FT under license. A contract was signed with the Van Dorn Iron Works Company, which was supposed to produce 4,400 tanks. Production began in the autumn of 1918, but progressed slowly due to technical difficulties and a lack of experience among American engineers. By November, only 952 machines had been manufactured, and not a single one of them managed to reach the front before the end of the war on November 11th. After the end of the First World War, France found itself possessing a huge stockpile of FT tanks, which were no longer needed in such quantities. The French government began an active program of exporting surplus armored vehicles to various countries of the world, and the FT tanks spread across all continents. Poland bought several hundred machines and successfully used them in the war with Soviet Russia in 1920. Finland received 32 tanks and used them against the Red Army. Romania, Yugoslavia, Czechoslovakia, Belgium, the Netherlands, Sweden, Norway, Spain, Portugal, Greece, Turkey, Iran, Afghanistan, China, Japan, and even Brazil. All these countries operated the French tanks at different times. Some states not only purchased ready-made machines, but also organized their own licensed production, as Italy did, producing about 100 tanks under the designation Fiat 3000. The FT tanks participated in almost all major and minor military conflicts of the interwar period. During the Spanish Civil War from 1936 to 1939, both sides of the conflict used these machines, although by that time they were hopelessly outdated and could not oppose the more modern Soviet T-26 and German Panzer I tanks. In China, FT tanks were used in battles against Japanese troops, but with minimal success due to the technical wear and tear of the machines and the lack of spare parts. By the beginning of the Second World War, FT tanks were still in service with several European armies, including Poland, Romania, and France itself, which used them as training vehicles and for guarding rear facilities. When the German army launched its offensive in the West in May 1940, several dozen old FTs were thrown into battle in a desperate attempt to stop the enemy's advance. The crews of these machines showed incredible courage, attacking modern German tanks and anti-tank guns in hopelessly outdated equipment. The result was predictable. Practically all the tanks were destroyed or captured in the very first days of fighting, and their crews were killed or taken prisoner. The German troops captured several hundred functional FT tanks and used them to guard airfields, railway stations, and other rear facilities in the occupied territories. Some machines were converted into self-propelled artillery units or armored personnel carriers. The last cases of combat deployment of FT tanks date back to 1944 and 1945, when individual machines were used by partisans and resistance forces in various European countries. Thus ended the combat service of the tank that changed the face of war and became the foundation for all subsequent development of armored vehicles. The little 7-ton FT lived an incredibly long life for a combat vehicle, almost 30 years from its first battle to its last shot. If you like this story about the legendary tank that was a whole century ahead of its time, be sure to like this video, write in the comments what other military equipment you would like to learn about, and subscribe to the channel so you don't miss new fascinating stories about the machines that changed the world.